Hey, welcome! There's this piece of math that's kind of secretly running your life, and you probably don't even notice it. I'm talking about linear inequalities. Sounds complicated, right? Well, I promise by the end of this, you're going to see they're actually super simple and way more useful than you think. Let's kick things off with a little puzzle just to see what I mean. Okay, picture this. You've got $500 in your pocket, and you have a serious craving for these amazing but kind of pricey $50 ice creams. But here's the catch. You promised yourself you would save at least $200, so you can't just go and blow all your cash. The real question is, how many ice creams can you actually buy? See, this is a perfect example of a problem where a simple equals sign just doesn't cut it. And this right here shows the difference perfectly. On the left, you've got a classic equation. That's what you'd use if you were going to spend exactly $500. But that's not our situation, is it? We have a limit. We can spend up to the $300 that's left over after we save our $200. And that little phrase, up to, is what turns this into an inequality, which you see on the right. Inequalities are all about these ranges and limits, not just a single, neat answer. All right, so let's dive in and take a closer look at what makes these things tick. These expressions that are so much more than just an equal sign. So what is a linear inequality, really? Well, at its heart, it's just a way of saying two things aren't, well, they're not necessarily equal. So instead of getting one clean answer, like x equals 3, an inequality gives you this whole family of answers, a whole range of possibilities. Think something like x can be any number bigger than 3. It's that idea of a range of answers that really gives them their power. Okay, to get good at this, you gotta learn the language. It's like a secret code, but way easier. Let's break down the 4 key symbols you're gonna see all the time. And here they are. You've got your less than and greater than signs, the classic alligator mouths, right? You've seen those. But the ones to really watch are the ones with that little line underneath. That line means or equal to. So you have less than or equal to and greater than or equal to. That tiny line is a huge deal. It means the number you're comparing to can also be part of the answer. That's a game changer. All right, time for the main event. How do we actually solve these things? Well, I've got good news for you. It is almost exactly the same as solving a regular old equation that you already know how to do. Almost. There is one crucial exception. Let's call it the golden rule. See, the first few steps should look super familiar. It's the same stuff you do for any equation. Step 1, clean things up. Combine any like terms. Then you start moving things around with addition and subtraction to get your variables on one side and your numbers on the other. So far, so good, right? This is all stuff you've done before. But this is where we have to hit the pause button. Because this right here, this is the spot. This is the one place where everybody messes up when they're first learning this stuff. So what happens when a negative number gets involved? Specifically, when you have to multiply or divide by 1. And here it is, the golden rule. You ready? When you multiply or divide both sides by a negative number, you have to flip the inequality sign. It completely reverses. A greater than sign becomes a less than sign. A less than or equal to becomes a greater than or equal to. Seriously, this one single rule is the secret to getting these right every single time. Let's actually see this in action. It'll make perfect sense. Look at the example on the left. We're dividing by a positive 2. Pretty standard. And notice the greater than sign doesn't change at all. It just stays put. No drama. Okay, but now look at the right side. To get x by itself, we have to divide by a negative 2. And the second we do that, bam! That greater than sign flips right around and becomes less than. That, my friends, is the golden rule doing its thing. So you've solved it. You've got your answer. But wait a minute. It's a whole range of numbers, not just one. So how in the world do you show that? Easy. You visualize it. And that's where the good old number line comes in. It makes everything crystal clear. Okay, before we start drawing, let's just nail down 2 quick terms you'll hear. First is the replacement set. That just means all the possible numbers you could even consider. It's like the whole universe of options. Then you have the solution set, and that's the good stuff. That's the specific group of numbers from that universe that actually make your inequality true, your final list of winners. Now, when you put your solution on a number line, you've got one big decision to make. Open circle or closed circle. And it's super simple. If your sign is just a plain old less than or greater than, you use an open circle. Think of it like a fence. It shows you where the boundary is, but the fence post itself isn't on your property. The endpoint is not included. But if you've got that or equal to line, you fill it in. You use a closed circle to show that, yep, that endpoint is absolutely included in the solution. Okay, let's try one. How would we graph the solution for x is greater than 2? Okay, check it out. You see that open circle right on the number 2? That's so important. Since our rule was strictly greater than 2, the number 2 itself doesn't count as an answer. So the open circle is saying, hey, our answers start right after this spot. And then the arrow pointing to the right, that just shows that every number bigger than 2, 3, 4, 5, a million, they're all part of the solution. All right, let's do another one. This time, let's graph x is less than or equal to 4. And boom, here's the other side of the coin. See how that circle on the number 4 is all filled in? It's solid. That's because of that or equal to part. It's telling us that yes, 4 itself is a totally valid answer. And, of course, the arrow pointing to the left shows that all the numbers smaller than 4 are also solutions. Okay, so we know how to solve them, we know how to graph them, but what's the point? Where do you actually use this stuff? Let's bring it all back to real life. The honest truth? You are using inequalities all day, every day, and you probably don't even realize it. Think about it. Your budget? You need your spending to be less than or equal to your paycheck. That speed limit sign on the highway? Your speed has to be less than or equal to 70 miles per hour. Setting a savings goal, you want your balance to be greater than or equal to your target. See, anytime there's a limit, a minimum, a maximum, you are living and breathing inequalities. Look, if you remember only one thing from this whole explainer, make it this. Solving an inequality is basically the exact same process as solving an equation. You just have that one single solitary golden rule to remember. If you multiply or divide by a negative, you gotta flip that sign. That's it. That's the whole secret. So now you've got the tools. You know the code. You can spot these things everywhere. So I'll leave you with a question. Now that you know what to look for, where are you going to see an inequality out in the wild today? Is it going to be on your dashboard, in your bank account, on your to-do list? Start looking. You'll be surprised. Thanks for tuning in.